Hello everyone, Dr. Vaughn. I'm going to make another video for this week. We're in week 4, one more week to go. We're still looking at Anova. This is in chapter 13. I wanted to make another comment about the assignments in MindTap first. I'll reopen this assignment in just a minute, the chapter 13 assignment. In MindTap, we're going to be going through, or we have been going through each of these week 1, week 2, week 3, week 4. And I did hear from at least a couple students about this supplemental chapters. And when you pop this open, this is like all the other chapters that didn't really fit into a 5-week statistics course that's specifically for business managers. So these are some of the topics that will add more value to some of the things we've already done. Introduction to probability, what is a probability distribution, what are continuous probability distributions. This is the kind of behind the scenes, if you will, that makes a t-test work, that makes an Anova test work. That, you know, so this is some of the theoretical foundations for the statistical processes that we're actually doing. We talked a little bit about sampling and the sampling distribution, but here's more information about it. And then this interval estimation. So all of this stuff is kind of things that probably should have preceded week 2. And now this is for qualitative data, goodness of fit, and the test for independence. These are called chi-square tests. We are focusing mostly on quantitative data. And then this is linear regression, which fits a little bit with leading into the multiple regression. Anyway, long story short, these are just going to be optional, even if you click on some of these and they have some assignments in here that are marked as counts toward grading. So even though this has the red dot and it says counts towards grading, I'm just not going to require you to do anything that's in the supplemental chapters. You have plenty of work to do with the week 1, week 2, week 3, week 4, week 5 things. But these are recommended, like especially leading into next week, you might want to go over this simple linear regression, because how could you possibly understand multiple regression if you haven't already spent some time thinking about linear regression? That might be a topic for next week's guidance video. But for today, I just wanted to let you know that the exercises contained in here are optional. All right, let's go back to week 4, and let's look at this kind of overview of all the things you've been working on this week, which is multiple groups, group 1, group 2, group 3, group 4, and you're testing whether there's a difference between the means by examining the between group variance and the within group variance. So we're going to take a look at putting all these pieces together. Here, I'm going to open up the data file that has this thing on the robots. And I'm going to open it right up into Excel. And I'm going to run my Anova to get the sum of squares of the treatment, the sum of squares of the error, to get my Anova table, basically. And then the test statistic should be, that's the F, it should be part of that Anova table. And then the p-value, and then we'll interpret the p-value in order to get a conclusion. The one thing that's always been a little tricky, at least for me, is doing Anova in Excel. And so it always takes me a few minutes, maybe a few seconds, to make sure I'm using the tool appropriately. So the first thing I'm going to do is open up the data analysis tool pack. I'm not using Excel Miner here. I'm just going to use the data analysis tool pack. We have only a single factor, robot 1, robot 2, robot 3. Which robot is our factor? So I'm going to go Anova single factor. And now I'll put the input range, including the headers, the labels, and all the data. And it is grouped into columns. And I did include the labels in the first row. And then in the problem statement, it tells me to use an alpha value of 0.05. So I'll make sure I set that box to be 0.05. And then I'll put the output from my Anova single factor somewhere else on the page, maybe down here. And I'll press OK. And so what you get is this kind of summary. There are 5 robots. This is the sum, this is the average, and this is the variance. And then here's my Anova table. So I'm just going to expand this out so I can see it a little bit better. And basically, I just need to type all of these questions directly into Cengage, and then interpret them. Sum of squares of the treatment. All right, so that's the between group, the sum of squares, 330. The sum of squares of the error, that's the within group, that's the 692. The mean squares of the treatment, that's 110. The mean square of the error, that's 43.25. And then the test statistic is the F, that's 2.54. And the p-value here is 0.092. So, and they just want the range of the p-value. So it's between 0.05 and 0.1. And since p is not less than alpha, alpha was 0.05, p was 0.09. So since p is not less than alpha, we fail to reject the null hypothesis. We do not reject the assumption that the mean drawing teams are equal. But we fail to reject the null, and the null is that the mean drawing times are equal. And I need to continue taking this assignment. It looks like there's some more parts to this. This is question 1 of 8. Okay, let's check this part A. And looks like I did okay. All right, now let's go on to question 2. I may not have time in this video to do all 8 of these questions, but they all seem to be actually fairly straightforward. You do have this LSD value, so they're kind of taking you out that if there is actually significance, now you have to do this kind of post-hoc analysis to test for the equality of the means. And so the other thing that I noticed on this particular question is that you don't have that button to just load it automatically into Excel. So you may need to type these numbers into Excel in order to run your Anova. Once you get your Anova table, then you're going to be able to determine whether you reject the null or not. And then if you do reject the null, now you're going to go on and use this Fisher's LSD procedure, which involves kind of taking the pair by pair means and looking up this value and then comparing the difference between the means to the standardized value to determine where the significance lies. And I'm sure you practiced this earlier in the chapter as well. I'm going to skip this question. Let's see what else is in this assignment. All right, here's another example. They don't give you the data. You should type it in. It looks like they have the same number of samples, and it looks like you're doing basically the same kind of questions. Here, they're actually asking you the difference between the means. Notice that in the Excel table, they give you the means, the averages. So, this is going to be X1 bar, X2 bar, X3 bar, X4 bar. In this case, there's only 3 groups, so X1 bar, X2 bar, X3 bar. So you take these numbers and you subtract them from each other, and that gives you the difference, and then you take the absolute value of that. And then you're going to compare that to this LSD value in order to make a determination about whether there is a difference or there's not a difference between X1 and X2. So, 2 and 3 seem somewhat related to each other, building upon 1. Now we're looking at the randomized block design. Looks to me like we're creating our Anova table here, where now you have this repeated values. So it's kind of, I think of this like the paired samples t-test, but now with multiple groups. So I have these repeated values. And let's see, more randomized block design. Factorial experiment. Now we're going to go with the 2 factors. You got low, moderate, naive, declarative, procedural. So when you go to do something like this, it looks like we can download this directly into Excel, which is great. So when you go to do something like this and you go to your data analysis tool pack, now I'm going to be using that 2-factor with or without replication. And you'll have to get to know which one to use under what circumstances the data values being repeated or not. But there are 2 factors here. The 2 factors being low, moderate versus time pressure versus knowledge. So you'll get again a larger. You're testing the hypothesis here that there's a difference based upon factor A, the knowledge. There's a difference based upon factor B, the time pressure, and then whether there's an interaction between those 2 factors. So you have 3 sets of hypotheses. You make 3 kind of determinations about whether you reject or accept the null hypothesis based upon each of these 3 different p-values. and they kind of walk you through that down here. And another analysis of variance problem. This seems to be back to the single factor. Not really sure what's different about this than the ones that you did earlier on. And another factorial design. So 2 factors, system 1, system 2, and then the language, Spanish, French, German. All right, so looks like you got quite a bit of work to do here. If you have any questions about completing these ANOVA tables, and in particular the 2-factor ANOVA, it can be a little tricky at first, but use the data analysis tool pack. It'll help you create the tables. The tables populate most of the information, and then you'll have a little bit of work to do, not even so much down here on these problems, but the additional work that Excel doesn't really do for you is going to come into play in these ones where you're doing that LSD procedure and looking at the difference between the means. All right, this has been Dr. Vaughn. This is a short video. A few days left in topic 4, module 4. I hope this is helpful, and I hope that if I don't talk to you, you all have a wonderful and blessed Easter, and I'll talk to you again with a new guidance coming out on Monday. Have a great day.